Hello everybody to my new video, and welcome to everyone. And as usual, before I start with the actual content of the video, I would like to thank you all for the support you are showing towards my channel. And I really invite you to continue to show this support, subscribing to my channel. I will continue to post contents both in Italian and in English, trying to find a balance between the two languages. They are both important to me. And if you want to support my project in a more substantial way, you can actually check the description below this video, and you will find two links, one to my PayPal and one to my Ko-Fi. And so you can also support me financially, and with this kind of support I will actually be able to grow this channel even bigger. Okay, this is the usual intro to my videos, and now we can start with the actual content of the video. So I would like to continue with this series on basically complex equations, and today we start by writing down the content of the video. So we have complex equations, and today we will see these two different equations that they seems different, but they actually are very similar. So I will treat them in a single video basically. So we have e raised to z is equal to I, and then we have e raised to I z is equal to 1. And so we will see that basically these equations are very similar, as you can see from the structure. But before we actually start with the resolution of the equations, I would like to note this kind of symmetry that here we have like we can imagine this z is multiplied by 1, here is multiplied by e, while here the right hand side equation, right hand side of the equation is I, while here is 1. So we can think like we exchange the place of these two objects to obtain two different equations. So let's start with the first equation. So we have e raised to z is equal to I, and here basically we have to remember the formulas we all know for complex numbers, and we have that e raised to z can be written as x plus I y. This is equal to I. Okay, so now we remember that we actually think of the imaginary unit as basically e raised to I pi over 2. Okay, and so basically we substitute this here to obtain the following equation. We have e raised to x plus I y is equal to e raised to I pi over 2. Okay, and then now we convert this number in its trigonometric form. We can write e raised to x, which multiplies cosine of y plus I sine of y, and this is equal to so we expand this number in its trigonometric form to obtain cosine of pi over 2 plus I sine of pi over 2, and we all know that cosine of pi over 2 is actually 0. So now to solve this expression we have to equate the real part with the real part of the right hand side, and the imaginary part of the left hand side with the imaginary part of the right hand side. So we highlight these parts here. So here we have the real parts, and these are the imaginary parts. So we write down a system of two equations, and we have that e raised to x cosine of y, e raised to x cosine of y is equal to 0, and then e raised to x sine of y is equal to sine of pi over 2, and we know that this is actually equal to 1, so we can actually substitute this with its numeric value 1. And so now we can actually solve this system basically by inspection, because here we have that this whole equation here must be equal to 0, so this whole expression here must be equal to 0, and we have that we can pose x equal to 0 from the first equation. From the second equation we have that since this whole expression, this whole e raised to x sine of y must be equal to 1, we have that x is equal to 0, so this exponential is equal to 1. Then we have sine of y is equal to y 1, so y must be equal to pi over 2, and then we have to remember the periodicity of the sine function, so we can actually add, we have to add 2k pi, because we have to remember the periodicity of the sine function, with k belonging to the relative numbers. So now we have solved this first equation, and we can actually write the solutions in algebraic form as follows. So the real part is actually 0, so we have to write down only the imaginary part, which reads I, which multiplies pi over 2 plus 2k pi, with k belonging to the relative numbers. So we have solved the first part of this exercise. Now we want to solve the other part, and we have e raised to I z is equal to 1. Then again the procedure is basically the same. It's now that we have to adapt it to this different case. So we have e, we multiply I, which multiplies x plus I y, and this is equal to e, we can write here I, which multiplies 0, because here we have 1, and so we continue, and we have e raised to, this becomes I, and I becomes a minus sign, and this is y, and then we have plus I x, this is equal to, now we can expand the complex exponential in its trigonometric form as cosine of 0 plus I sine of 0, and we see that the roles of cosine and sine are now inverted, and obviously this part here will be 0, and then we will have e raised to minus y, which multiplies cosine of x plus I sine of x is equal to cosine of 0, okay, plus I 0. I'm writing down all explicitly in order to make this exercise as simple and as intelligible as possible, and then we have again to equate the real part with the imaginary part of the other side. Excuse me, the real part with the real part, and the imaginary part with the imaginary part of the other side. So we have e raised to minus y cosine of x is equal to cosine of 0, and then from here we have that okay, that cosine of 0 is actually equal to 1, and while the other equation reads e raised to minus y sine of x must be equal to 0. So from here, since we want these equations to hold, we can say that epsilon must be equal to 0 and x must be equal to 0 plus 2k pi, again because we have to take into account the periodicity of the cosine function. And then to complete this other part of the exercise, we can say that the solution written in their algebraic form read z is equal to 2k pi, and they do not have an imaginary part because epsilon is actually equal to 0 in order to satisfy these equations. And basically we have concluded our exercise, because again we write that k must be in the relative numbers, and so we take also into account the periodicity of the trigonometric function, and we solve the exercise. With this video I will finish here, and as usual I thank you for your attention, and we will see in the next video. Thank you.